We have students who can't be here because they have other classes, like at middle school and stuff. So I need to be able to record this for them. So just letting you all know we're recording this. Let's see. Okay, so I've got things all over the place here trying to keep track of. Good to see you all. You're looking good. Look at you with your mask on. Connor, where are you? Oh, do you have a microphone? I just noticed Connor was masked up, so I was wondering where he was. Oh, okay, cool. Trying to get that close. There we go. All right. Well, hello there, everybody. Brody, that is a red room with your name nice and big on those walls there. Cool. 1 o'clock. All right. Walt, what'd you have for lunch today? What'd you have for lunch, Walt?
I had Panera. I have some wrappers here.
Okay, nice. Yeah, I'm trying to get my volume adjusted here, so that's kind of one reason I'm asking. Maddie, what'd you have? Maddie Rogers, what did you eat for lunch today?
A ham and cheese sandwich.
Nice. Maddie, that is a very clean room. I'm impressed.
Thank you.
All right, I think my volume's good. I need to make sure I can hear you guys. All right, so today, and I am really in an effort right here to try to get all my classes on the same page by the end of next week. I don't know if you guys have heard about the new idea that they have for the schedule. Have they sent anything to you about that? I didn't think that they would. Some of you are saying yes. Okay, anyways, so I'm trying to get everybody on the same page by next week. So that's part of the reason that we're filming this as well. Also, period 2, 4, and 6 are going to be watching this video on Tuesday of next, or on Monday of next week. So hello, period 2, 4, and 6. Everybody wave to them. They're all going to watch this as their thing for Monday, and that just helps me get everybody on the same page. All right, so we are looking at section 4 in your notes packet here. So if you have that out, go ahead and grab it. And we are on section 4. Which is kind of the toughest section of this chapter because it's like word problems and application problems and stuff like that. Want to let you know as we go here, as we go along, if you have any questions or comments or anything that you need to say, please just unmute yourself and you butt in and interrupt me, okay? You have full permission to unmute yourself and just interrupt me and say whatever it is that you need to say, okay? I also, along the way here, will kind of be just kind of picking on people and asking questions. I don't think I'll ask anything too difficult. So just kind of be aware of that and be prepared that you might need to unmute yourself and answer a question here or there, okay? So without further ado, here we go. We are definitely not going to finish this whole thing today. We only have till 1:30, and I'm already 5 minutes in. So if you don't have the notes with you, you just can do the best you can on your own paper and you'll be okay. Uh-oh, Connor lost his queen. All right, Connor, might be time to pause the chess game. So I am able to share my document camera here. Let's see if it focuses. Not very good. Let's see if I can get this to focus a little bit better. I always check this before I start. Oh, there it goes. Nice. All right, so solve application problems by defining a variable and writing and solving an equation. So I need to make sure I'm very clear on what the objective in this lesson is. These are all problems that require us to define a variable and write an equation. Right? The whole idea of this whole chapter is solving equations. So these are going to be problems that require us to define a variable and write an equation. If I'm not clear about that objective, then it seems like just a big hodgepodge of different problems that don't have anything to do with each other, but that's what they have in common. The first kind of problem we're going to look at here is a consecutive integer problem. So let's just think about what that word consecutive means. Right? If we say that two numbers are consecutive, what does that mean about those two numbers? Liam, what does it mean to you for numbers to be consecutive?
They're one after another?
Or one after another. Sorry, Liam, is that twice I've picked on you today already?
No, I don't
That's
think
the
so.
first time? Okay. Yeah, they're one after another. Now, I also want you to think about what it would mean to say that two numbers are like consecutive even numbers or consecutive odd numbers. So consecutive evens would be like 2, 4, 6, 8. Consecutive odd numbers would be 1, 3, 5, 7, 9, and so on. But if we don't say even or odd, then consecutive is just 1, 2, 3, 4, 5. So in example 1, it says 4 consecutive odd integers have a sum of 336. So we have 4 consecutive odds. Let me kind of make a visual for you here. Okay, so I've got an odd number, and then another odd number. You can't see that, sorry. And then another odd number, and then another odd number. In between these odds are evens. Okay, if we add up all these odd numbers, they have a sum of 336. Okay, now let's play a little game here. Let's play guess the number, okay? What if I told you that this first odd number was 17? I just made up 17. If the first odd number was 17, think about what the next odd number would be. So Joaquin, what would the next odd after 17 be?
19.
I'm sorry?
19.
19, you got it. And then we can figure out what all the rest of them are. So if we know what the first odd number is, we have to add 2 to get the next one, and add 2 to get the next one, and add 2 to get the next one. All right, now suppose that I tell you that that first odd number is just X. Well, let's do the same thing to get to the next odd number. We still have to add 2. So the next odd number would be X plus 2. The next one, we'd add 2 more and have X plus 4. The next one, we'd add 2 more and have X plus 6, okay? So I just made up 17 just to show that we just add 2 to get to the next odd. Well, if we start with X, then we still keep adding 2 to get to the next odd. All right, that's what we call defining a variable, and we need to write that down when we show our work. So let's say X is the first odd integer. Then the second odd integer, you would take that X and add 2. So X plus 2 gets you to the next one, and then X plus 4 gets you to the third one, and then X plus 6 gets you to the fourth one. Okay, anybody having any issues there? Remember, you just let me know, you just butt in. So this is talking about 4 consecutive odd integers. So now I have a way to represent all 4 of those odd integers. They have a sum of 336, meaning if we add all those up, we should get 336. That sounds like an equation to me. So let's add all these up. We'll take the first one, and then we'll add the second one, and then we'll add the third one, and then we'll add the fourth one. And that's all supposed to add to 336. One thing that can trick people up sometimes is the fact that these are odd integers, but we're adding 2, 4, and 6, which are even, right? But we're just adding 2 each time so that we skip the even that's in between each of the odds. Okay, I'm gonna have you guys go ahead and simplify the left side here. Go ahead and simplify that left side, add everything up. It's so funny because I look over and I can see you guys like talking to people who are in the room with you. Somebody yesterday had their cat in their room with them. I thought maybe I should bring my cat into school with me every day.
I have cats. I should probably go and get one.
My cat would just pee all over the room. I'm not going to give him that opportunity. Oh, also yesterday when I was in a Zoom meeting, my internet kind of got funky for a little bit and I kind of froze and everybody froze on my screen. We just kind of waited it out and it took a minute or two and everything got better. Okay, so we should be looking at the left side of this equation. Let's just add up the x's. Drew, how many x's did you have on the left side there?
I had 4.
4 x's, and then Drew, I'll go ahead and stick with you. What you have 4x plus what?
12.
4x plus 12 equals 336. So we should have 4x plus 12 on the left there. Alyssa, is that what you got as well? Yes? Okay. Then we can just subtract 12 from both sides. So I have 4x equals 324. Divide both sides by 4. I need 324 divided by 4. Let's see, 4 goes into 32 8 times. 4 goes into 4 once. I've got 81. All right. It is so easy to just say, there we go. We solved for x. We're done. But we haven't actually solved or answered this question yet. I want you to look at why we haven't answered this question yet. We solved for x. Somebody wave at me if you can tell me why we're not finished. Wave at me if you know why. Liam, why aren't we done yet?
Because the question is asking what the value of twice the greatest number is minus 3 times the least number or smallest
That's right. There you go. We need twice the greatest decreased by 3 times the least. Now, the reason that we do this is because we want you to get used to finding a solution, but then not being finished, right? And we actually do something with the answer that we found, okay? That's a great habit to get into so that we don't always just stop once we found the variable, but then we get in the habit of doing something with that answer. So what we have found here is that the first odd integer is 81, right? That's what we found. Well, now we know that the next one's 83, and the next one is 85, and the next one is 87, all right? I've got some note cards here that I've been using, but I have to dig one out. Give me just a second. My desk is such a mess. I bet my desk is messy.
Clean it.
Messier than yours. Clean it?
Clean it.
Well, you know. Whatever. We'll just use this. Okay. So now, when it says, what's the value of twice the greatest decreased by 3 times the least? Well, the greatest is 87. So I'll do twice the greatest. Decreased by, we all know that means to subtract 3 times the least. So 381 is the least. And we can work that out. So let's see, 2 times 87 is 174. 3 times 81 is 243. Is that right?
Yeah.
Yeah.
174 minus 243, we got a negative number there, and we'll just roll with it. Nothing said that our answer can't be negative on that one, okay? So this last part, like I said, is just to get in the habit of doing something with the answer that you found. What we really need to get in the habit of is how to define these variables for these consecutive integer problems. All right, let's go on to example 2. This time, we have 3 consecutive integers. They're not even, they're not odd, they're just integers. 3 times the least decreased by 4 times the greatest results in 25. We want the middle one. All right. Now, this time, the integers are not even, nor are they odd, so we don't have to skip over an even or skip over an odd. So let's say we've got 3 consecutive integers. Let's say the first one is x. Let's think about what that next one would be. And they're not even, they're not odd, they're just consecutive numbers. If the first one is x, let's see, can you figure out what the next one would be? Olivia, what do you think?
X plus 1.
X plus 1. That's right. And then Eli, what would the next one be? Eli, what would the third one be? Do you know? If you don't know, just say, I don't know.
You said X plus 2 in the chat.
Oh, we did. Okay, sorry. X plus 2 is correct because we don't have to skip any, so we're just adding 1 each time. So let's go ahead and write that down and define our variables. X equals the first integer. X plus 1 is the second one. And X plus 2 is the third one. This defining the variable step is required. You have to write that down because when you set up your equation, we have to know what the heck X is. Like we have to know where X is coming from. All right. Now it says 3 times the least. Let's look at these 3 and decide which one of these is the least. And it's obviously X because that's the first one. So we need 3 times the least. So that would just be 3 times X. Decreased by 4 times the greatest. Well, the greatest one is that X plus 2. That's the biggest one. So it's decreased by 4 times the greatest. And that results in 25. All right, now I'm going to ask you, if you were the teacher here, and you looked at this equation, what would you tell a student to be sure that they didn't forget? Or what mistake might people make here? Wave at me if you've got an idea. What would you tell a student? Connor, what would you tell them? I don't know if are you able to talk?
Don't distribute.
Oh, well, we will in the next step, but just in setting up the equation, what's a part of this that some people might forget and leave out that would make the problem wrong? I don't know why I'm not, oh. Okay, the negative because of the parentheses. Or I'm sorry, the negative because of the decreased by. I just gave away the answer that I was looking for, but it's the parentheses here. Make sure you don't forget to put in the parentheses. The greatest number is X plus 2. That whole quantity represents that greatest number, so we got to keep that in there. Now, when we distribute, whoever said, distribute the negative, or somebody said something about the negative, that's an important one, because when we do negative 4 times 2, that gives us minus 8. So that is something that people forget to do. 3x minus 4x is negative x. If I add 8 to both sides, I get negative x equals 33. So x is negative 33. It's okay that it's negative. So we've got 3 consecutive integers here. The first one is negative 33. This is asking us for the middle one. I'll be really careful here because we're dealing with negatives. What number is 1 bigger than negative 33? Blake, what number is 1 bigger than negative 33?
Negative 32.
Negative 32. That's right. Because they're negative, it's real easy to go, oh, 33, then 34. Well, nope, they're negative. So one bigger than that is negative 32. That's our answer. Okay? So we are defining variables and writing an equation. And then, of course, you have to solve the equation. But these first 2 parts is what's really important here. All right, let's do one more problem. Let's turn to the next page because we've got like 9 or 10 minutes. Let's do one more problem. These are applied geometry problems. We might be able to get 2 done. I don't know. We'll see. My goal was to get 2 done on this next page. That's something that's really difficult for the teachers, is knowing like how far we're going to get with stuff here as far as like when we're planning. All right, totally different problem, but we're still going to have to define a variable and write an equation. So the length of a rectangle is 5 centimeters greater than its width. The perimeter is 58. Find the area. Probably a good idea for us to go ahead here and draw our rectangle. It says the length is 5 greater than the width. So let's go ahead and just say the width is W. And if the width is W, we should be able to come up with an expression for the length, because the length is 5 more than the width. So Lulia, do you have any ideas on how we might label the length here?
W plus 5.
You got it. W plus 5. Now, guys, I'm totally fine with this being your defining the variable step, okay? If you want to write out and say, let W equal the width, that's awesome. But you've drawn a picture here. We all know what W represents, and that's what's most important. Now, perimeter means the distance all the way around, so let's write an expression for that. We've got a W here and a W there. So that means when we add all the sides, we'll have 2 W's. Okay, let's add that to the other 2 sides. I've got a W plus 5 and another W plus 5. So I have 2 W plus 5. So it's 2 widths added to 2 lengths. That gives you your perimeter, and that should add up to 58. Let's go ahead and work that out. Distribute my 2. 2W and 2W is 4W. So 4W equals 48. So W is 12. All right. Everybody shake your head, yes or no. Is that the final answer to this problem? No. We're supposed to find the area. Area is length times width. So what we know now is that the width is 12. If the width is 12, then Brody, what's the length of this rectangle?
17.
17. You got it. The length is 5 more than the width. So the area is 12 times 17. That's not something I can do in my head. Some of you might be able to. 204 square centimeters. Okay, define a variable, write an equation, then do something with your answer. That's the idea here. We got time for one more. I bet we can get this done in less than 5 minutes, and then we will have accomplished my goal for today, which is to get through example 4. Here we go. The sides of a quadrilateral, 4 sides, right? 4 sides to a quadrilateral are in the ratio of 1 to 2 to 3 to 6. If the perimeter is 138, what's the length of each of the 4 sides? All right, I need to caution you about something here. You know what? I don't like drawing my quadrilateral that way. That's not very realistic. You're going to get to hear Mr. Shockley here.
Could you please call extension 5011? Catherine, please call extension 5011. Thank you.
Yay, it doesn't have to do with me. All right, quadrilateral. Let's see. I don't know. There's 4 sides. Now, I need to make sure you understand that it says these are the ratios of the sides. These are not the side lengths. Okay. The smallest side does not have a length of 1. We don't know how long the smallest side is. So let's call that X. What I do know is that the next biggest side is twice as long as the first one. Okay, so however long the smallest one is, you have one side that is 2 times that length, one side that is 3 times that length, one side that is 6 times that length. So if this side is x, the next biggest side is 2x, the next biggest side would be 3x, and the next biggest side would be 6x. This problem is easy once you define that smallest side as x. Because they gave us ratios here, they did not give us side lengths. The perimeter is supposed to be 138. Perimeter means add them all up. So x plus 2x plus 3x plus 6x, and that's supposed to be 138. Okay, well, this is a pretty easy one to solve. Let's add 1 plus 2 plus 3 plus 6 would be 12. 12x equals 138. I want to point out here real quick that when you do a problem like this, make sure that you write down this equation. Don't just add these in your head and go straight to 12x equals 138. I know you guys are capable of doing that, but this step here is crucial as far as communicating, hey, they gave me the perimeter, here's me doing the perimeter. Right? That gives me that communication there of what you're doing. So make sure you keep that step. 138 divided by 12 is 11 and a half. We're not finished. We have to do something with that answer. We found the length of the smallest side. The next biggest side should be twice as long. So 11 and a half times 2 would be 23. The next side after that is 3 times as long as 11 and a half, which would be 34 and a half. The biggest side is 6 times longer than that, which I think is 46. Can I get a, is that right? 6 times 11 and a half is 46? No? What did I do wrong?
You did 4 times instead of 6 times.
Yeah, I did. You're right. I doubled the wrong number. I should have doubled the 34 and a half instead of the 23. That makes sense. Okay, there it is. So I forgot to tell you we're supposed to be pretending like today is Tuesday since it's last period on Friday, but at least it's only 1:30 and not, 2:50 or whatever. Okay, guys, we've got 2 more geometry problems and then these motion problems. We are going to get into that. Let's see, the next time I see you, which will be on Tuesday of next week, we will have a video lesson to finish all of this out, okay? Our next Zoom meeting will be next Thursday, but it's going to be real quick. It's going to be like 20 minutes. It'll be a quick one, okay? Cool. Now, if anybody wants to stick around to, if anybody has any questions on homework or questions on what we did today or questions on anything else, you are welcome to stick around for that. If you just want to stick around to see if other people have questions and just kind of learn from them, that's great. I will stay here as long. Well, I have a meeting at 1:45, so I have 15 minutes. If anybody wants to hang around and ask homework questions, you can. Otherwise, if you don't need to do that, you are welcome to go, and I will see you in person next Thursday. Okay. Have a good one. Do you guys actually have bells? I can't imagine. All right. Anybody have, you guys have homework questions? Nope, she's gone. Connor, you're gone. Lulia? Lulia, do you have any questions for me? All right. I'm going to go ahead and end this then. Goodbye.